Hi, I'm Prantik Howladar. Today I'll be talking on Beyond Pixels, semi-supervised semantic segmentation with multi-scale patch-based multi-level classifier. So semi-supervised semantic segmentation involves training a segmentation network on limited label data and a large amount of unlabeled data. And existing approaches typically use a teacher-student framework. The challenges in this field include consistency, is that all these methods have maintained consistency at pixel level, not explicitly exploiting context information. The existing approaches like convolution networks like AEL, they're restricted by kernel sizes, while transformer-based methods like segformer cannot be applied here because the amount of data is very low. So existing supervised methods also introduce a secondary problem because the teacher network needs to generate pseudo labels for unlabeled images, which is noisy. So coming to the motivation for this problem, context is important for pixel level segmentation. So let's see. Let's see the class of the pixel with star. Now this pixel belongs to a tire, and this can either belong to a car or a truck. So the class of the pixel depends on the context inside the red box. So you see why context is so much important for segmentation. So we propose a solution which involves processing patches within an image. So to introduce contextual information and also detecting noisy labels within a patch. Like, say we have an image and we have a patch which is inside this red box. Now, this red box patch not only includes one class car, but it is having multi-classes. So this is a multi-level classification problem. So if we are able to classify this this patch, we can see that it can be classified in different classes inside the patch. If there is a class that is not inside the patch, the corresponding prediction for that class will be low. Confidence for the class will be low. This can be used for removing any noisy prediction of say truck in that patch. So a proposed solution involves a novel plugin module called Multi-Scale Patch-Based Multi-Level Classifier (MPMC), which consists of two adaptive ways that reduce the influence of noisy pseudo-labels. We have further validated our method by integrating into 4 state-of-the-art semi-supervised segmentation methods with consistent improvements in both natural and medical dataset. Now let's see how our method works. So given these patches, we see how the segmentation network after 20 training epochs predicts the corresponding class. In the orange boxes are classes predicted that don't belong even to that patch. So here you can see it predicts a truck, while the corresponding multi-level classifier is actually able to perfectly predict the classes. After training, we observe that our method improves the baseline by improving segmentation in the regions marked by white bounding boxes. Coming to the overall pipeline. So we have a student-teacher network. This is the overall pipeline where the segmentation network is trained with cross-entropy loss and multi-level classifier with asymmetric binary cross-entropy focal loss. So let's go through each of them one by one. We have labeled image and unlabeled image, which is a classic teacher-student network, where LL is a labeled cross-entropy while LU is unlabeled cross-entropy loss. LML is now we train the MPMC multi-level classifier with asymmetric binary cross-entropy loss, while for unlabeled images we should train it with LMU is the unlabeled loss. Now this for unlabeled images, this loss can be the predictions can be noisy. So to reduce the